Good morning, everybody. Thank you, Mr. Chairman, for the introduction. And thank you, the organizer, for inviting me to participate in this panel discussion. When I was asked to do this, I scratched my head for a few minutes, saying, what should I do? What should I say? Am I representing a community? Which community? The earth science community, maybe say, let's say the geologists, but not only. Should I think of something new infrastructures? And then I said, wait a minute, there is an infrastructure that is not exactly new, that has proven to be very successful, and we should make sure this is maintained because of the several benefits that we got in the last 40 years at least. So I centered this on scientific drilling, generally speaking, and I will describe this in the next 15 minutes or so. But before that, I also went to the basics. So what is infrastructure? Okay, we depend a lot on the Commission. So according to the Commission, the infrastructures are instruments for bringing together a wide diversity of stakeholders, very general, to look for solutions to many of the problems that society, okay, this is an important thing, we need to help society. We know that Europe puts society as the primary goal of science, and they have to be unique. They need to provide a service that is unique. They are conceived in three types: single-sited, distributed, and virtual. These are the infrastructure. So today we talk about a distributed infrastructure, a scientific drilling. And then there is a forum, strategy forum for research infrastructure, you know, probably everybody, it's called S3, that is developing a strategy and is putting money for the preparatory phase of new infrastructures, but not for the running of the infrastructure. Let's remember that according to Europe, they help us building an infrastructure, and then the running of the infrastructures is on national funding. Ocean drilling has always been on national funding. There's been little or no funding from Europe or other funding agencies. Then there is this Merrill portal, also funded by the Commission, which is a database on inventory of the most excellent infrastructures in Europe, and there are hundreds of them. For them, the definition is the infrastructure is a facility, or also a virtual facility, that provides a scientific community with the resources and services to conduct research in the respective fields. Very general definition. Criteria to be elected a infrastructure is based, criteria are three, based on quality, access, open access. If an infrastructure is not accessible, is useless, and the management of the infrastructure, that has to be very good. Yesterday I searched this portal with the keyword marine, and I got 97 infrastructures in Europe, mostly vessels, oceanographic vessels, but not only. So we are talking about a big range of tools to do science. Okay, my hypothesis here is that scientific drilling is the most successful and long-lasting distributed infrastructure in the field of earth science, working on the ground, leaving aside ESA, which is probably bigger. But with scientific drilling, the scientists and even the students can access physically the infrastructure. So you don't go to a satellite. You use the data of a satellite. We will see how important is the observation of the Earth from space. In this case, the observation of the ocean from a drill ship from the data can be performed directly by the scientists, by us. So the story began in 1958 when the US and the Soviet Union were competing for being first in everything, even in space science, and there was a lot of military and economic interest in it. And some people said, who cares about the space? We want to know what's below our feet, and especially to sample the transition between the crust and the mantle, the Mohorovicic transition. And it is most accessible from the ocean. So they decided, let's hire one of these primitive drilling vessels that the industry uses and drill for it. They tried with little money. The technology was not really ready. They failed. The Mohole project was very ephemeral. And then the scientists in the US got together and they launched the deep sea drilling project with a proper vessel that was all the time available as an infrastructure to the American scientists. And they started this adventure. In the end of the DSDP, there was a phase called the international phase of the SDP, where the Americans invited other scientists to go and say, look what we're doing. Are you interested? And then with the next phase of the contract with a company to hire this vessel, which is the JOIDES Resolution, then the funding started to come from European countries, from Japan, Australia, Canada, and others. So they opened up the infrastructure to whoever wanted to contribute for it. Another 10 years and IODP, so the infrastructure was only one. Then we entered the multi-platform phase, 3 drilling ships with IODP that lasted until today. And from October 2013, which is today, there is a new phase of the program, which is called the International Ocean Discovery Program, still the same acronym, IODP. And that's where we are. We are here. And we need to plan for the next 10 years of scientific drilling. The 3 platforms plus 1 are the CQ, a riser drilling system. This is one of the most advanced drilling platforms existing on the Earth, working also for the industry, part-time for the program and for the industry. The older, but I mean, a ship never gets too old because it can be refitted and renovated continuously. So very efficient, for sure. JOIDES Resolution, managed by the Americans. This is managed by the Japanese. And then Europe manages the mission-specific platform. So if there is a need for science that these 2 vessels cannot fulfill, then they hire a different vessel, like in the Arctic. They went, and this is for the coral reefs, very shallow drilling. And then let's not forget that ICDP, continental drilling, belongs to the same program. So you can also access sediments in lakes or coastal areas through platforms, drilling, rigs drilling from land. Very quickly, what is the meaning? What are the capabilities of this vessel? Deep sea drilling, the resolution and the CQ. The CQ with the mud circulation system can drill deeper and prevent the fluids to get out on the seafloor and on the ship for safety. And so this vessel can drill into environments safely that this vessel could not drill. However, this vessel is faster, robust, has proven excellent recovery, and it will still be central in the program. And then in special cases, you have the mission-specific platforms. Okay, what is so important of the program? Just some highlights. There are many more, but I picked the one I like most. The program allowed to test and confirm the plate tectonics theory. Can you imagine that? A total revolution in earth science. The drilling proved the existence of intact volcanic crust below the marine sedimentary sequence, another breakthrough discovery. It helped define and refine the geological timescale, reconstruction of planetary history and life, and the global sea level change. In other terms, paleoceanography owes a lot to this program. It helped develop the seafloor borehole observatory, so observations are also part of the program. It began to study the fault zone behavior, so how earthquakes occur in Japan, and this is ongoing. And it demonstrated the existence of a deep biosphere within the sediments, down to 1.6 kilometers below the seafloor. This is an opening to biology and microbiology especially. So we're not really talking only about geology of Earth and earth science. There is a scientific streamline for the next 10 years, which is described into this Illuminating Earth document available on the internet. It is downloadable. 4 pillars: climate, deep life, which is biology, planetary dynamics, and geohazards. There is a lot of societal relevance, and I am proud, I would say, to have contributed to including the geohazard as part of the science to be addressed by IODP. Before this new 10 decade, geohazard were not part of that. And this is paying attention to society. The programs in general, ODP, IODP, DSDP, they drilled the oceans all over the place, Antarctica to Arctic, mostly in the Pacific and in the Atlantic Ocean, and also in the Mediterranean. And now we are scaling down to our Mediterranean area. So the second part of my hypothesis is that the next decade of scientific drilling, including the use of the riser drilling, possibly, hopefully, provides a unique opportunity to explore the subsea floor of the Mediterranean and the Black Sea. We talked about this yesterday, whether the ship can go through under the bridges on the Bosphorus, but eventually they can manage it. To do what? To understand climate history, deep sea resources, the deep biosphere, geohazard, and the deep crustal structure of the Mediterranean and surrounding regions. These are important aspects. So, among the highlights, I left out to take it back here, one of the most interesting ones. One of the highlights of the program of scientific drilling is the discovery or recovery of extensive layers of salt deposits deep below the bottom of the Mediterranean Sea, proving that it had dried out repeatedly in the past. This discovery was in 1973, exactly 40 years ago, and the Americans were so interested in this that the New York magazine in 1974 put this in the cover. These are the Gibraltar waterfalls and the people leaning to look at it. So the program did, even in the initial stages, something that caught the imagination of the people. Even the Americans, which are not Mediterranean people, published a cover like this. It was not published in Italy nor in Switzerland or in France. I'm talking about Italy and Switzerland because the three authors of the major paper are from these countries. This is a map where you can see where this salt is distributed in the Western Mediterranean in green and in the Eastern Mediterranean in yellow. And we now know, with the, especially with the effort put together by Joanna Lofi, to identify these seismic markers, we have a much better definition than before where the salt is in the deep basins. So this event, geological event, unique, we think, in the geological history, at least in the recent ones, changed the chemistry of the global ocean, had a permanent impact on both the terrestrial and marine ecosystems, and the subsequent structural evolution of the Mediterranean basin. And think that more than 1,800 scientific publications have been published since then, in the last 40 years, about 1,000 of which in the last 10 years. So the interest in this is growing and growing, besides the discovery was made 40 years ago. So, another time arrow, the SDP, the first drilling in the Mediterranean, the first breakthrough Nature paper by Ken Shu, Bill Ryan, and Maria Chita, who said the Mediterranean dried out. Not everybody really agrees on that. Like some do, others don't. There is still a big debate. Then ODP, so this vessel went back. These are the white dots. 5 minutes? Finito? Okay, so I'm going to finish. And they drilled again, but avoiding the salt. The salts could not be drilled because of safety. The onset of the advent of IODP with the possibility of drilling with the riser made the scientists think that the CQ could go and drill through the salt. And so an initiative started. There was a series of workshops. The last one was this, and I put this photograph because Maria Chita, Bill Ryan, and Ken Shu got together with young students and other scientists to think how we could address this with drilling. And the last thing I want to say is that this initiative called DREAM, I think I put it on the previous slide, yes, here, DREAM, Deep Sea Record of Mediterranean Messinian Events, actually germinated in a CIESM workshop in Almeria in 2007. So this is the importance of CIESM. A workshop can put a community together, a conflicting community and make them agree that they should agree to try to solve the problem instead of just fighting with papers, scientific papers. So this is going on. I don't want to continue too long. This is an open initiative. This is open access for proposals. So anybody interested in all these topics, please contact us and you can come on board. The next meeting we have is in Paris in January 2014, and we will start writing the proposal. Thank you.